I will be explaining the meaning of differentiation and what are the techniques of differentiation. Differentiation is a fundamental concept in calculus. It deals with how fast one variable changes with respect to another. In short, differentiation tells us the rate of change of a function. Differentiation helps us to find rate of reaction. So geometrically, it shows the slope of tangent line to a curve at specific points. Next, I'm going to explain the technique of differentiation. The technique of differentiation has 10 of them, but we usually use 4 in class. The first one is power rule. Power rule is used to expression that adds to the power of n. Second is product rule. Product rule is used when two functions are multiplied. Third, the quotient rule. The quotient rule is used when one function is divided by another. The quotient rule is used as a composite function when function is inside another function. That's all from me.
Hi, Assalamualaikum. My name is Nurul Alisandra Bintabullah. So today I'm going to show and explain to you guys about question number 2 for A part. So for this question, it asks us to find dy dx for 2x4 tangent 1 plus 2x. For this question also, we have to use the product rule, which is u prime v plus uv prime. What is u, what is v? U and v, we're going to get it from the separation of this question, which is u, v. So here, you also have to find out the u prime, v and v prime. U and v is the original state of this question, but u prime and v prime is the differentiation of this question, which is for u part, you're going to get 8x cubed, and v part, you're going to get 2 secant squared 1 plus 2x. For this one, how do I get it? First, you have to differentiate the tangent first. After you differentiate the tangent, you're going to get secant squared. And then, this one you have to rewrite them in the original state, 1 plus 2x. And then you have to multiply it with 2. Where do I get the 2 from? 2 is the differentiation of this bracket formula. So after all, you have to multiply all the equation to get this one. 2 secant squared 1 plus 2x, which is the v prime. So after you got all this term, you have to substitute it into the product rule formula. So after you substitute, you're gonna get this one. I already substituted it for you guys. So after you substitute it, you have to expand all the equation to get the proper answer. So this is all for question number A. For question number 2, for second part or B part, this is the question. For this question, we have to use the quotient rule. What is quotient rule? The formula is u prime v minus 2v prime over v squared. From this question, same goes to the A part, we have to separate it into u and v. And also, we have to find the u prime and v prime. I remind you that u prime and v prime is differentiated from this equation. Okay, from this term, we can substitute it into the formula of quotient rule to find dy dx. So when you substitute it, you will get this equation. After you get the equation, same goes to the A part, you have to expand it to get this equation. After you get this equation, to get the proper answer, you have to simplify it to get the proper answer. So this is the dy dx of this question.
Hi, my name is Sanira. Today I'm going to explain for question number 3. This is the equation given and we need to find dy dx using implicit differentiation. First, we need to apply chain rule to each term with respect to dx. As you can see, there are 3 terms. So we need to apply the chain rule to each of the 3 terms, and then we need to differentiate each term using product rule. This is the first term, this is the second term, and this is the third term. After we 1 to the front and this to the back of equations. And then we need to solve for dy dx, leaving dy dx as a subject. And as you can see, this is the final answer for derivatives of dy dx. That's all.
Hello, my name is Rizna and I will show you how I calculate equation 1. So the equation is this, and the answer need to be in the 3 decimal place. So first of all, we need to define fx. So let's for sure equals to this, and get this answer. So the next step is I use the first derivative because I want to find the instantaneous rate of change of a function. So I will use this step and intern this. So the next step is I use approximation formula. So this is the formula. 8.03 I use as a new value of x, and this is the old value of x. X naught equals to 8.03 and delta x I got this. So I replace the value in this formula. So we got this answer 1.955.